One of the great things about this is, and I know me as a is you get to buy a new radio. I know a lot of people don't want to do that, but it's these radios are really neat. And one of the things that we decided to do when we put all the AMS stuff in here, we said we have a digital radio that's analog capable, is we went ahead and threw all the analog features that you find in the VX8 and the VX7 and some of our other radios into the FT1DR, which includes APRS, full narrowband and wideband FM technology, toning, code, decode, anything that you're going to find in any of our other radios, including enhanced page encoded spell system, is built into this radio. So just because we put digital into it doesn't mean that we cut off any of the analog side. You have an integrated GPS in all of our System Fusion radios. They all have APRS in it, including the FT2DR, which we're getting ready to release here soon. And the VX7 and some of C4FM, I'm going to get more into some of the modes that we're operating. Of course, bit, error rate characteristics is the main reason that we chose C4FM. But we also have the highest audio quality on the market right now as far as digital radio goes. And how did we do this? Well, since we do have a wideband repeater, we have a little bit more bandwidth to work with. We came out with what's called voice wide mode. And that's where we took the full 20 kilohertz of bandwidth that we have available. We're pushing as much data as we can through it to provide a high quality, high fidelity digital audio signal. It is absolutely superb, and I just recommend that everybody grabs the demo radios I sent around at any point, key them down, talk to somebody, listen to the quality of the voice. It is absolutely outstanding. Go to the next screen. 4 modes of operation. The first mode is our VD mode, or voice and data mode, also known as digital narrow. It allows us to transmit data at the same time as voice. Now, if we're not transmitting data, it does use the other slot for forward error correction. So we get a little bit more distance out of the system. We have a little bit more error correction in the signal that decreases that bit error rate when we start having a really broken up signal with a lot of QRM and maybe some intermod in it. So we'll get a little bit more distance out of the digital narrow mode. Now, if you know you're within communications range, we have the voice FR or a full rate mode. Voice full rate mode is going to use the entire bandwidth just for voice. Nothing else. No data, no text messaging, no telemetry. The only thing that's going to come over is voice, and it's going to be much, much higher quality. We have a data full rate mode. The data full rate mode is high-speed data transmission. It's twice as fast as the digital narrow mode. It's used for stuff such as text messaging and image transmission when there's no voice actually present on the radio at that time. And of course, we have standard analog FM modes, which are going to support repeater access, offsets, PL, DCS, all the standard features, including APRS. I can't stress that enough. All of these radios have a very, very nice APRS system built right into them. There are a few features that we added that changed the game up a little bit. Now, C4FM and FDMA that's been used in P25, we're not doing. And I know a lot of people weren't happy that we came out with another technology when P25, DMR, D-Star, NextEdge, IDAS, all these technologies are out there. What I tell everybody, it's one more to add to the bucket. It's not a bad thing because we're developing this stuff right now. We're trying to figure out what amateur radio wants. Yaesu's taken a really good stance on this, though. We've actually provided all of our engineering information to the general public. You can get right on the website and pull down all the information you need to build your own fusion hardware, your own fusion radio, to decode and demodulate our signals or modulate your own. So we have all that stuff that's out there. It's a little bit vague, and the reason is it's a supplement to what we have. We expect people to actually prime themselves on P25, know what's happening so they can compare and contrast our documents when they're engineering their own hardware. So we made it easy, but we didn't make it too easy. We want people that are actually capable of developing hardware doing so. So Yaesu's really, really trying to help in that aspect. One of the reasons that we went to, go back to that slide real quick. Probably back twice. It's made an animation. One more forward. Okay. One of the reasons that we had to change up the protocol slightly is we put stuff in there like digital group mode, image transmission, text messaging. When we started doing this stuff and it was amateur specific, we started handling call signs. We started putting call signs in these packet headers. We had to change things up, and they weren't going to be compatible with any type of P25 radio because we had to make an amateur technology. We weren't going to release another commercial technology onto the market. Some of the stuff we put into the radios, like digital group monitor, are really, really impressive features if you're working with emergency communications. One of the things it enables us to do is monitor RSSI to and from a repeater site or to and from individual simplex radios. If you have a net control station that's running an operation, let's say in search and rescue, and you have a group of people that are using a repeater and you need to monitor when they're going to be in or out of communications range, this is an invaluable tool. The digital group monitor function also allows us to store telemetry and send group text messaging. That means that you can actually save and store coordinates and track down those coordinates from your net control station or individual client radio. If another station starts yelling bloody murder, they need help, they're out there, help me, their radio dies mid-transmission, we're saved. System Fusion is actively transmitting in digital narrow mode their telemetry information as they're transmitting. That means if that radio dies and loses a battery right mid-transmission, we can store their location and we can backtrack right to where they're at. And I think that myself, and just coming out of Joplin, Missouri, where we had a massive tornado, I think that's invaluable. That if we have somebody that we need to locate, we can locate and store their information, pull up the compass on our radio, and go right to that member of the group. So a few things that we changed up, and if we go to the next slide. One of the ones that I like, it's not the most impressive feature, but it is a heck of a lot better than slow scan TV, is digital image transmission. We have a VGA image that can be sent. It can be transmitted to an FTM 400 displayed on the screen, or it can be transferred and stored to an FT1DR or FT2DR portable radio for retrieval later on your PC. So another thing that we changed up a little bit, we had to put that stuff into our System Fusion system, and it changed the protocol and signaling technologies just slightly. The smart navigation function, which I just talked about a minute ago, we can store someone else's location and track ourselves right to it. Great for search and rescue. We can do this on simplex as well as in the digital group monitor function. If the operator, the transmitting operator, actually has their GPS enabled, when they're in digital narrow mode, we'll get that telemetry data sent over automatically when they key down. You'll see the distance you are away from the station that you're talking to, and you'll see their heading as well, so we know which direction they are. If you're sitting down talking and you have some beams up there and you need to actually point your beams to the location of the other station, it's going to give you a direct heading of that other station, how far they are away from you. We can save those locations into memory slots, and as I mentioned before, we can track ourselves right to them. Next. The backtrack function is interesting for those of us that go camping, hiking, fishing, or are working search and rescue. When you get to the command side or command post, we can automatically store the location of wherever we're at. We can pop the radio on, we can load that location at any time, and backtrack ourselves right to it. So another little feature, of course, it's not a strong one in the radios, but when you need it, it's there to use. We can go next. The DR1X repeater, to touch on that slightly, we are selling the DR1X repeaters right now for $500 a piece. We were including 10 free shirts with them, but we just extended the program into June 30th, and we'll be running it through June 30th, and actually the program won't be ending until the end of 2015. So we have some new stuff coming out. There's going to be some announcements at Dayton. Of course, we like to, as a manufacturer, wait and surprise everybody with a little something at Dayton. So things are coming, and I urge everybody to look at the dates and the expirations of some of these programs. When they expire, we'll be releasing new exciting stuff. The DR1X repeater features we've already talked about, just to go over a couple of them real quick. It is a 50-watt repeater at 50%. That means you cannot key it down continuously at 50 watts. They do have some problems doing that. We found that out about halfway through our testing process of these repeaters. Now, we put a feature in there that they would automatically cut power back based on heat. That didn't work too well. We found out that amateurs are great about continually abusing the repeaters, so it just doesn't help. We do recommend they be run back at 20 watts with a power amplifier if possible. They do have battery backup built into them. They're a 19-inch rack profile, as you can see up here, with a nice color touchscreen on them. So they're fully front panel programmable. That opens up another opportunity to emergency communications. If you guys are backpacking these things, as I like to call them, or running these up to remote sites in the event of emergencies, putting them in the back of emergency communication bands, they can actually be reprogrammed right from the front panel wherever you're at to adapt to any type of situation. One other option repeaters have is to actually work in unidirectional crossband operation, meaning rather than lug around a big set of duplexers, we can now carry a small diplexer with us and run out one antenna with minimal losses. So about 1.5 dB to 2 dB insertion loss. You put a diplexer on the unit, you receive in UHF, you transmit in VHF, and any one of our current radios is fully capable of operating crossband with these repeaters. Go ahead, hit once more. It's going to keep hitting. There we go. There's a 15-pin rear accessory connector in the radio for analog compatibility. This doesn't work on digital. There's no digital decoded audio. We intend for wires X to be used to interconnect these repeaters. I'm going to get into that in a moment, because one thing that everybody wants to know is why Yaesu didn't release a repeater with internet connectivity. And that's really interesting, because when I first got my repeater from Yaesu, they were marketing it as an independent system. They never really had intentions of interconnecting these repeaters. They wanted it to be more of an isolated type of digital solution within a community. Later on, we found out that people wanted digital connectivity. We started moving that direction. We started adapting our hardware, and we're still doing that. So digital connectivity is on the way, but we're just not quite there yet. There's no digital decoding. Wires X is the system that we're going to use to link both analog and digital. It will work with the repeater in hybrid mode. Right now, it only supports the FTM 400. If you can hit that again, it should bring out some of the text there. It does work right now with the FTM 400, and that's our test bed for this system. We have roughly 100 nodes right now on Wires X in the United States. There's a system fusion net that goes on every Tuesday that's about 30 to 40 people strong. Most of the net controls based out of Atlanta, Georgia. We found the system to work very, very well. The next step is, and we're going to do a release announcement around July to August about Wires X digital linking into the DR1X repeater. But right now, we're kind of in the initial stages of developing what we want it to do and how we want it to work. So rather than release a product that's not ready, we all know how happy people get when products are released and aren't completely ready for the market. We went ahead and held off and said we're going to give it a few more months to perfect exactly what people are going to want into the system. The HRI 200 interface is the heart of the wire system. Unfortunately, I didn't have one to bring with me tonight. My show equipment didn't get back in time from, let's see, where was it? In AES Superfest in Milwaukee. So we had a full show booth there, and my shipper just really isn't Johnny on the spot. So we plan on having a 991 here. We plan on having some other stuff here for you guys to look at, but we don't have it here at the moment. I'll go give you a brief overview of the HRI 200. If you look at it, it's very similar to something like you see in a rig blaster or signaling, and that's pretty much all that it is. It's a really fancy version of the sound card interface that supports C4 FM digital. That being said, the radios that are available now are the FTM 400, the FT1DR, the FT2DR is our new touchscreen radio that's just about to hit the market. They should be shipping by the 7th to the 15th. They're a really neat radio. I just got a chance to put my hands on one the other day, and I can say the touchscreens are very responsive. It's nice having some extra knobs and controls on them. I think that everyone's going to be very, very happy with the release of the FT2. It's absolutely a revolutionary radio, not just in ham radio, but in the entire radio community. There's no touchscreen radios out there on the market. And that we're being the people that pioneer that in amateur radio, I think that's really fascinating, because we really don't see as many people pushing technology or pushing new technology in amateur radio these days. So we are leading the way in amateur radio. Everyone has seen that with radios such as the FTDX 3000, the 1200, where we're now putting the really, really nice, very responsive LCD screens into the radios. We have a lot more computer-controlled technology in these radios. They're firmware upgradable. We're able to fix problems with them now and push out firmware updates really, really quick to the community, and just keep everybody a little bit happier. So it's been really, really nice being able to stand behind these products. I wanted to mention to everybody as well before I get done here that we are going to have another Q&A type presentation at Ham Radio Outlet in San Diego this Saturday on the 4th. I'll be there all day to answer any questions, more one-on-one. If anybody would like to bring in any of their Fusion radios and have us program them, look at them, show you how to do stuff on them, that's the point of that day at Ham Radio Outlet. So I'd like to thank everybody, and if there are any questions, I'll take those now. Just raise your hand and we'll get to you. Sir in the back.
I heard you saying earlier something about 20 watts and more than that, you use an amplifier. What is the linearity requirements of the amplifier for the digital radios?
Well, it's just response time. If the actual TR relay is any slower than about 300 milliseconds in the amplifier, you might see some issues on this recovery time as far as, getting some digital image transmission or text messaging in and out of the system.
Oh, I was saying linearity requirements. I mean, I'm a digital tech. I work with digital amplifiers all the time, and about 90% of the amplifiers you get off the market will not work with a digital radio. Because
the TPLs are the ones that I really recommend because of the response time, and that's been the biggest issue that we've found. Now, I've ran a lot of different amplifiers on these units. I don't have actual technical specifications of it. I know that we have a response time requirement that's under 300 milliseconds as far as transmit and receive goes. Other than that, just about everything we've thrown on them's work. So we have a variety of amplifiers running those.
In other words, they're not critical for pulse rise time.
Not at all.
Okay.
Yes, sir.
I got two questions. First question, C4FM, is it a proprietary codec or is it public domain?
We're using the Ambi 3000 vocoder, and that's the only proprietary part of it. And I don't like using that as far as saying proprietary, is we're just buying the vocoder for wanting to experiment with this technology. So
software to replace all that.
Yeah, it would be nice, but unfortunately with what DBSI and how they license it, they want to license that chip. Yeah. So, you got to buy the $5 chip if you want to develop the technology. That's one thing.
The next question, why such an incredibly low data speed like 9600, which is basically useless?
That was entirely up to the engineers in Japan. We know we could have pushed it a little bit further than 9600 kilobits per second.
Is it the same concept that did with D-Star with the Japanese MIDI, how letting the faster It
was engineering's decision on that one. There are a few ways that I think that we could have done it better. And the nice thing about this all being firmware upgradable is as we get these requests in from the community, we can push it a little bit more to engineering to actually make some of these updates in the software. So
that bandwidth that you've got 12.5 kilohertz.
I'm sorry, I can't hear you.
With the bandwidth of 12.5 kilohertz.
Yeah, we could probably get up to 38.4 is what we could actually do. Well, I mean, as far as reasonably, we could probably do 38.4, but I don't see Japanese engineering changing any of that anytime soon. They're gonna go with the current standards, what's in phase 1 P25. So it's gonna be more along the lines of that. They'll change it up more as the phase 2 stuff gets adapted. We will move into the future with some of that stuff. So there's expandability there, but the system's in its very first stages of infancy. And we're currently trying to get this information back to engineering. There's no way that I can develop this stuff with Japan without getting these exact kind of comments from you. Yes, sir.
Years ago, I was involved in pagers that had a problem, and they didn't know technology now, but they had a huge problem, and digital paging was sitting next to analog paging. And you have essentially 20 kilohertz of solid white noise sitting next to an analog FM signal. Have you done any kind of comparisons about what you're going to do with basic channel repeaters or basic channel these various voltages and things like that?
That's one of those things where really field tests are going to tell us a lot more about how the technology is going to perform. From P25 tests, we know kind of how things are going to go. Our receivers are pretty selective inside of the DR1X, so as far as it coming into the digital, not as much. I don't worry about it as much as I worry about analog interference next to it. But so far, we haven't had any negative reports along those lines. I take data reports still every day.
TV signal, for example, is a solid block of
Right.
noise. And I'm assuming yours is holding the whole.
Yeah, it is. If you look at it on a spectrum analyzer, it looks a lot different. So.
By adjacent channel signal, you can create
Yeah, and I have not seen it on a spectrum analyzer yet, so I'm not sure how it does affect anything really close. That's more of an engineering related question that I would have to actually query Japan and say, have you guys actually done these tests on it? Yeah, I haven't tried it myself personally, but I try to collect all the information that I can as far as, this type of technology goes. As people are testing it, I'm taking these reports and saving it into a database so we can answer these type of questions. Yes, ma'am?
If you look in April's, there's spectral reports of all the nodes of the HD. So you can see the spectral in those.
Okay, what was that in again, ma'am? Okay, wonderful. You guys actually put that in a newsletter. That's amazing. That's great. It's April QSD. Okay, I haven't seen that yet. Yeah, I think I just got that one delivered. Yes, sir. The GPSs are built right into the radios. Yeah. Right into, on top of on the face of the FTM 400 and on the top of the FT2D and the FT1D. Now the FT991 or HF radio requires a 4800 baud and MEA GPS extra, so doesn't have one built in. Yes, sir.
Is this digital standardized, or is this digital format standardized, or is it proprietary?
It's not standardized, but we did provide all of our engineering information online. So there is a digital guide that goes through how our signals are encoded, our datagrams, everything like that is available on our website. If you go to the DR1X page under the files section, you can actually download that guide. And it's pretty much a compare and contrast guide against a lot of the P25 guides that are out there. So
I got a question.
yes, sir.
Yes, my question is, I'm a visually impaired person. I was programming the radio. It was very difficult to do. I had these magnifying glasses. Has anyone thought of adding some accessibility, some sort of voice guidance that can be toggled on, or some add-on?
We have in some of our HF lines, but putting it inside of the actual portables is going to be a little bit hard and mobiles because of the limited space. Now the 400, the FTM 400 and the FT2DR does have a larger screen on it. So you're looking at about 4 times the size of the screen on the FT2DR. So you're going to have a lot bigger of a display on that. So it's going to be a little bit better for the visually impaired. But as far as voice guides, we really don't have that on the planning table yet.
Would you also like to see if, I would like to see if blind repeater, maybe you have a blind repeater on a guy owns a repeater, he wants to program his box, there's companies out there.
Yeah, and the computer software is one thing that we're looking at. We definitely look into aspects for the handicapped, visually impaired. We don't want to cut anybody out of playing with the technology. So as it develops, those are some great things that we can use as far as feedback. One of the things I've been instructed to do by the owner of the company is to provide them with an adequate amount of feedback every month from our customers. That's one of the reasons that I'm here. Yaesu isn't round filing any of these comments or suggestions that you're providing with us. And I have business cards that I can give anybody that's interested in this room in providing us any type of feedback that we can use to make these radios better. And one of the things that we're going to do is we're going to categorize it. If you get back to me in about a month, we'll actually let you know where you stand as far as possibly getting this feature implemented. So, yeah. Yes, sir.
Yeah, I'd like to get a bit more idea about the actual operation. Say you have 2 guys out there talking to a guy that's analog, can you hear them?
No, he can't. Now, if he does break in, well, the repeater and the way this repeater is set up right now is to automatically take the incoming signal, whether it's analog and digital, and it's going to convert it to fixed FM. So if you're talking through the repeater and a digital station comes on or an analog station comes on, nobody's going to know the difference. So it's going to automatically take the incoming signal and it's going to convert it to FM on the transmission side. Yeah, so it'll go either way, digital to analog or analog to digital. So people. On the analog side of stuff, if you don't have a system fusion radio, it can't switch into digital. So there's no way that it can decode or encode the digital format. Now, on the FT1DR, what will happen is if an analog station tries to break into a digital conversation, meaning if you hear a digital signal and you key up, their radios will automatically revert over to FM and they're going to hear what you're saying. And then that will give them the opportunity to switch over to analog, or if their radio is actually set to the AMS mode of where it reverts to analog and stays, then they'll just stay on analog, and the next time they key down, they'll be talking back to analog.
I'd like to piggyback on that. I think we're not talking back to the same. I think your question is, these two guys are talking digitally. And an analog station comes on. And here, if it's set up that way, will switch to analog.
Right, it'll switch to and from analog or digital. So if you have a digital conversation going on and the repeater's set in automatic mode, meaning that whatever it hears, it transmits as. So if it hears digital, it transmits digital. If it hears analog, it transmits analog. That's another mode that repeater can be put into. So it will switch back and forth. Now with automatic mode select on the client radios, they will switch between analog and digital as that repeater switches its modes as well. So the guys talking in digital, if they have automatic mode select turned on, as soon as the analog station keys up, they'll switch over to analog FM as well.
Always using analog radio. What exactly is going to happen with that? So talking, you switch the whole computer over to analog.
Yeah.
And so you try to talk digital and then talk analog.
If they have automatic mode select set up, then their radios will automatically start talking analog back to the repeater. Now, if they want to go ahead and force themselves into digital and not even care about the analog guy, they can keep going. The analog guy can still keep keying up, and he can still use the repeater. Not simultaneously, but it will switch back and forth, but it won't do it simultaneously. So that kind of operation is more of a conventional hybrid operation you're going to see in the commercial world, like P25 hybrid repeater or a DMR repeater running mixed mode. So it's going to switch either or, but it can't convert. And that's the thing the System Fusion does differently. It'll actually take that analog or digital signal and convert it back out to FM. So a little bit more interoperability in there. Not much more, but a little bit more. Yes, ma'am?
What's the interface out for the microphone camera?
The microphone camera, I do not have that. Japan has actually not released that to me yet. We've asked for it. We know that there's some serial communications going on in there at TTL level, but we do not have a pin out yet, unfortunately. When we get one of those, we'll be putting it online, though. We have asked. Yes, sir. Actually, not yet, but the FT991 will do C4FM on HF. So, yeah. Yeah, well, there's a 10 meter and a 6 meter net that happens weekly right now here in the United States. Just amateur. Well, on the repeaters, yeah, the repeaters are just 2 meter and 440. 2 meter and 440, yeah, amateur FM. Just swapping the gear, yeah. It's a fully self-contained unit, power supply, battery charger, programs right from the front screen. Everything's inside what you need. No special digital stuff. As a gentleman in the back mentioned, you can get some nicer amplifiers for digital that will improve the signal quality significantly. So, yes, sir.
There's nothing to prevent us from making a translator using one higher frequencies, is there?
More power to you. Yes, sir.
Can you repeat the part about the crossband repeat?
It will unidirectionally crossband between 2 meter and 440. So you can receive or transmit on either band unidirectionally crossband. Now, it's not bidirectional like you would notice like a lot of our 8900s, 8800s, and FT and 400 will do, but it will do one way. So you can't go both ways with this. Yes, sir.
I happen to have some top things for you.
I'm sorry.
And both FNY, narrow, and ultra.
Right.
And they cover 2 meters. from like 130 to 174.
Right.
I mean, I'm just amazed at the technology. Now, obviously, you cover a lot of cities on the bands to talk to other out-of-range things, but you're mostly using for this radio.
Right.
Are these radios basically 400 to 470 and 134 to 174?
Well,
And you've just tripled them?
yeah, they are amateur radios as a manufacturer. Unfortunately, if I was here, just as myself, Chris Inzer, OCSW, I could tell you a lot more about the radios, but being here representing the company, I can't say anything about their transmission range, but we all know where they'll go. Yeah.
All I'm asking is because if this technology takes off and it is superior to a lot of digital technology, I can understand that these things may end up becoming the factors for the commercial radios.
I don't think so because of the way that the signaling works right now. This is a wideband technology. So it's not narrowbandable. I don't see it going over into the commercial world at all.
So you're limited to the 20 kilohertz.
Right, and there have been some fail-safes put inside the DR1X repeater. If you try to modify them to open them up as Mars cap mods that we do on the 400s, it will disable the repeater. So the repeater controller will freak out, and there's nothing we can do to recover it at that point. It's got to go back to Japan for the program. Oh, yes, sir. Yes, sir. Yes, it does. Yes, it does. It has several locking functions, a manual and an automatic lock. So it works pretty well. What I've gathered on it as far as brushing up against them, it's not too responsive to that. So it requires a very specific touch in a precise area. If you get too wide of an area on the screen, it just locks it again. Yes, sir. If you're going to use it as just analog, no. If you want to use it as analog and digital, there's going to be some stuff that you want to do. We do recommend using the ARCOM ADR1 interface that was just made by ARCOM controllers. It makes the analog and digital integration with an external controller work a little bit better. So we are adapting our firmware to work like that controller unit, so it won't be needed in the future, but right now we do recommend that specific series of controller. Either that or the SCOM that integrates very well with it. So it does have the capability. We have a lot of people that have them on IRLP and EchoLink, so the external interface, the actual external interface connector seems to provide the signals that we need to do that kind of stuff. No problem. We'll take a couple more here, and then I've got to start heading back to Huntington Beach. Yes, sir.
As far as the duty cycle and power output, it seems like the DR1X did a lot better on 2 meters and 70 centimeters as far as failures. Is that what you noticed personally?
I think it has something to do with the series of transistors we use and the ratings that they have. At UHF, they're actually rated a lot lower than they are at VHF. So there might be some truth to that. I haven't got a response back from engineering that says, yes, that's the case, but they've kind of been looking into some of those failures and what they are. Now, the reason that we haven't been pushing the research into what's going on is because the amount of returns we've received really haven't been that high. So once they start getting up to a point where we consider them a problem, then I think they'll push it a little bit more. But for the amount of units that we actually have out on the market, we're just not seeing as many returns as we've had with some of the other product lines. Yes, sir. Right back.
Everybody's far too technical for me. I just want to know if they're using this program. And when you're talking about these liquid displays, are they the ones that are on the handy copies too?
Well, no, they're LCD displays, but they're not full color displays. Just to answer that question, on the FT2DR, it's a monochromatic touchscreen display, and they are very easy to program. One of the things about Fusion is you just pop in the frequency, tell the radio it's digital, and you're going. So there's no special programming, no talk groups, nothing to put in there that's really complex.
Does it do away with tones?
Well, yeah, there's no digital tones. There's no digital squelch or NAC codes or anything like that, unless you want to use it. And we have what's called digital squelch, which is the equivalent of a P25 NAC code.
Okay.
And, okay, I'll take one more. Yes, sir?
If you do a software update on the manual reading,
about halfway through, you decide to use it, it's not going to fix the upstream, you gotta be able to use it on the
We will fully support the unit. Unlike the other manufacturers, if you break your radio, we'll take care of it. Not a problem.
Do you program it with a cable or?
The unit comes with the cable. Yeah, everything you need is in the box to do firmware updates and programming. Well, thank you everybody for having me tonight. As I mentioned, free radio.
Chris, thank you very much. I think we've been pleasantly covered with Chris's willingness to talk about some details of how products are developed, saying I've got to get back to engineering. If you've ever worked with a group of engineers, sometimes getting the engineers to pay attention, you have to hit them across the side of the head with a baseball bat. We're gonna do this, right? We're gonna do this. But, last call for any tickets who somebody may wish to pick up at the last minute. Anybody in that category? No. So